Hello there, Mr. Sutton here, bringing you the IM3 Honors Chapter 6, Quiz 1 Extra Practice Solutions on Simplifying Rational Expressions. To simplify this rational expression, I need to first make sure there's no common factors, and to do that, I'm going to factor out my denominator so I can see what I'm dealing with down there. So it looks like I can take out a 16 from both of those, and also an x, because they each have an x, so 16x. So that makes 32x squared into 2x. And then negative 16x, that's going to become a minus 1. So these x's outside the parentheses can definitely cancel. And then 36 and 16, I can reduce those. Those are both divisible by 4. So 36 becomes 9, and then 16 becomes 4. And again, those x's got canceled. So we've got a 9 over 4 parentheses 2x minus 1. To simplify this expression, let me make sure there's no common factors, and let me start that by actually factoring to see what the factors are. So in the numerator now, I need factors of negative 45 that add up to negative 4. So we got 1 and 45 doesn't work, 3 and 15 is no good, 5 and 9 would work if I had positive 5 and negative 9. So x plus 5, x minus 9. All right, 1 down, 1 to go. Let's do the denominator. We need factors of 54 that add up to negative 15. So 1 and 54 doesn't work, 2 and 27 doesn't work, 3 and 18, well, that would work if one was negative and one was positive, but they both have to be positive because it multiplies to a positive, or they actually have to both be negative. Multiplies to a positive, adds up to a negative, so let's keep going. How about 6 and 9? Well, yeah, negative 6 and negative 9 adds up to negative 15. So we have x minus 6, x minus 9. And now these common factors of x minus 9 will cancel, so that leaves us with x plus 5 over x minus 6. To simplify this expression, since I'm multiplying, let me actually factor and cancel out whatever I can and then multiply. So in the upper left here, I can take out an x, leaving me with an x plus 5. And in the lower right, I can take out a 7. That's x plus 5 left over from that. I can cross-cancel these x plus 5s because I'm multiplying the fractions, so cross-canceling is allowed in that one situation. And then 9 and 24, those can reduce by 3. So 24 is now an 8. This 9 down here is now a 3. Multiplying the leftovers, we have x times 8, which is 8x. And 3 times 7 in the denominator gives me 21. To divide these rational expressions, let me turn this into multiplication by multiplying by the reciprocal. So same, change, flip. Keep the first fraction the same. Change this to multiplication. Flip the second fraction so that this 9x minus 36 is now the denominator of that fraction. And just like any multiplication problem here, let me go ahead and factor and cancel whatever I can before I even think about multiplying. In the upper left then, we can take out an x, leaving me with an x minus 4. In the lower right, I need lower left actually, need factors of 14 that add up to 9. 1 and 14 doesn't work, but 2 and 7 does. So x plus 2 and x plus 7. In the upper right, we need factors of negative 35 that add up to 2. 1 and 35 is no good. 5 and 7 works if you have negative 5 and positive 7. So x minus 5 and x plus 7. And in the lower right, looks like I can factor out a 9, leaving me with an x minus 4. What cancels here? Well, it looks like these x minus 4s can cross-cancel because I'm now multiplying. So multiplying allows you to cross-cancel. Because if you did multiply right now, they would just end up in the same fraction anyway. These x plus 7s across from each other can also cancel. And it looks like that's it. So in the numerator, I have an x times x minus 5. In the denominator, I have this 9 and an x plus 2, and that's as good as it gets. To subtract these fractions, let me first make sure I have a common denominator. Looks like I do. They both have an x squared minus 81. So let me just keep the denominator and add the numerators together, or subtract as it were. And I'm just going to write things out just so I don't make any mistakes. So 40 minus 3x, that's still up there then. And now we subtract this numerator. I have to distribute a negative to both terms of the numerator. So we have a minus 94, and minus minus is a plus 9x, so careful on that one. Combining like terms up there now, we have, let's see here, a negative 3x and a 9x. I'll just do the x's first. So that's going to be 6x. And then 40 minus 94, that's negative 54. Let's double check to see if we can factor and cancel. So in the numerator, I can take out a 6, leaving me with an x minus 9. In the denominator, these are both perfect squares, so I can square root and use my plus minus parentheses. So x plus 9 and x minus 9 in whatever order you want to write them. And then it looks like these x minus 9s cancel. So that leaves me with a 6 over x plus 9. To simplify this rational expression and add these, I need to get a common denominator. Let me first factor my denominators, and I can use those factors to put together an LCD and turn those both into that. So for the first denominator, I can take out a 3. That leaves me with an x plus 8. For the next one, looks like I can take out a 5. That leaves me with an x and a plus 8 as well. Dealing with the 3 and the 5 first, the smallest number 3 and 5 both go into is 15. So that's part of our LCD. And then we also have an x plus 8, and that covers both of these x plus 8s because they both appear at most once in a denominator. So now let me multiply each fraction by what it needs to get the LCD. For this first fraction, we've already got the x plus 8, but that 3 needs to be a 15. So I'll multiply by 5 over 5. And I'm doing 5 over 5 so that I'm actually multiplying by 1, not changing the value of anything. For the next fraction, I have the x plus 8, but I need a 15, not a 5, so let me multiply by 3 over 3. Actually multiplying those out, for this first setup now we've got a 10 times 5, or 50 in the numerator, and this is going to be 15x plus 8 in the denominator, which was the LCD that we were trying to get. For the second fraction, 4 times 3 gives me 12 upstairs, over 15x plus 8. I've got the same denominator, so let me just keep that. And let me add the 50 and the 12 in the numerator. That's going to be 62. Can I reduce this at all? I should always double check. Well, 62, it's not divisible by 3 or 5, and that was really it for interacting with the 15. So it looks like this is fully simplified. On this problem, to simplify, I need a common denominator. Let me first factor the denominators and see what's going on down there so I can put together my LCD. So all that really needs to be factored is this lower left one here. So let's see, factors of negative 10 that add up to negative 3. We've got 1 and 10, that's no good. 2 and 5, if I had positive 2 and negative 5, that would work. So x plus 2, x minus 5. And then my LCD, it looks like that's going to be an x plus 2 and an x minus 5. And that x plus 2 covers both of these x plus 2s because they appear at most once in each denominator. All right, so let me multiply each fraction by what it needs to get this LCD. First fraction's actually good the way it is. It is the LCD down there. For the second fraction, though, we have the x plus 2, but we lack the x minus 5. So I'm going to multiply by x minus 5 over itself, and that really just means I'm multiplying by a fancy form of 1, so that I'm not really changing the value, but I make it look different in a useful way. So let me rewrite that first fraction because nothing happened there. For the second fraction, I'm actually going to multiply this out. So in the numerator, I have x getting distributed. That's going to be x times x is x squared, and then x times negative 5, that's negative 5x. Denominator is just going to be x plus 2, x minus 5. No need to actually FOIL that out. We just wanted to get the LCD down there. Since I do have the same denominator, let me just keep that common LCD denominator and combine the numerators now. And I've got a whole bunch of things I'm adding together up here. Let me just do this from highest to lowest exponent. So I've got an x squared that I can't combine with anything else. I've got a negative 6x and a negative 5x. That's negative 11x. And I've got this 30 that has nothing to be combined with, so that's just a plus 30. Now that I've added these together, let me just double check and see if I can factor and reduce. I should always look for that at this point. Are there factors of 30 that add up to negative 11? Well, we've got 1 and 30 doesn't work, 2 and 15 is no good, 3 and 10 is no good. How about 5 and 6? Well, yeah, negative 5 and negative 6 adds up to negative 11. So I've got x minus 5, x minus 6, and hey, it looks like those x minus 5s actually can cancel. So that leaves me with x minus 6 over x plus 2, which is as good as it gets.